Let's move on to rule number 5, moving the summing point ahead of the block. So right now we have a summing point over here. The inputs to the summing point are A and B. So both are plus. So the output of summing point will be A plus B, and this signal A plus B is moving through a block with gain G. So this A plus B will get multiplied with G, and the final output would be A plus B into G. Okay. So here what I am trying to do is I am trying to move this summing point in front of the block or ahead of the block. Okay, so after applying rule 5, our summing point will come over here. Okay, so then the signal A would directly go to G like this. A will go to G, and the output of this block will now become A multiplied with the G, AG. So now this AG will go to the summing point, because we have shifted this summing point in front of the block G. So right now this is the position of the summing point, and one of its inputs is AG, and to the summing point we had one more input, that was B. So here if we provide B directly, the final output, which is the output of this summing point, would be AG plus B. But the signal that we actually require is A plus B into G, that means AG plus BG. So what we require is AG plus BG. But if we provide this B directly to the summing point, what we will get is AG plus B only. So in order to get AG plus BG, in this path we have to place a block with a gain G. So then only here we will get BG. So to the summing point, if we have AG and BG, this summing point will give the output AG plus BG, which is equal to A plus B into G. So if we do this kind of shifting summing point, then we have to make this change in the path. Okay, so moving on to rule number 6, moving summing point before the block. So initial case we have the summing point over here, and we are trying to shift this summing point before the block. So let's check. Here we have a block with gain G. We are applying input A to the block, and the block will produce an output AG, and this AG will go to our summing point, and to the summing point we will also provide another input, which is B. If this is the case, the summing point will give the output AG plus B. Okay, so now we are trying to apply this rule 6 to this particular system. So then we have to shift this summing point before the block, but the input should be A over here, right, and the final output should be AG plus B, right? Okay, so here we have shifted the summing point here, and we are providing A as one of the inputs to the summing point, right, and the output of the summing point is provided to the block G, right? Okay, fine. And here we are providing A to the summing point, and if we provide B as such to the summing point, then the summing point will produce A plus B, right? So that A plus B will move through this G and will produce A plus B into G. A plus B into G means AG plus BG, but the final output that we actually require is AG plus B only. It's not AG plus BG. So the output that we actually require is AG plus B. That means we cannot provide B as such to the summing point. If we provide B as such to the summing point, the final output would be AG plus BG. But what we require is AG plus B only, right? So what we do is B is applied to a block with the gain 1 by G. So that will produce signal B by G. So that B by G is applied to the summing point. then the summing point will give A plus B by G. Now this A plus B by G signal will move through the block with the gain G. So what will happen is A plus B by G will get multiplied with G, and that will finally give AG plus B, right? So here we have to add a block with the gain 1 by G, then only we will get the actual output AG plus B. So that is rule number 6. Rule number 7, it's just interchanging the summing point. We have two summing points. The first one is having the inputs A and B, and the second one is having inputs this A plus B. The output of first summing point is connected to the second summing point, and the third signal is C, but here the symbol is minus, so it's minus C. So in this case the final output would be A plus B minus C. Okay, so when you interchange the summing point also, the basic inputs will be A, B and C, and the final output should be A plus B minus C. So I am shifting this summing point to this point and moving the first one to the position of the second, just interchanging the two summing points. So after interchanging, the first one will be having the inputs A and C. C is minus, right? So this first one will produce an output A minus C. Okay, so that A minus B is applied to the second summing point with the other input as B. So we have A minus B plus A minus C plus B, which is same as A plus B minus C. So just interchanging the two summing points. Then splitting summing points. Sometimes in our block diagram we will be having a summing point with 3 inputs. If that is the case, then we have to split it into 2 different summing points, each with 2 signals or 2 inputs. So here we have a summing point. The inputs are A, and that is plus. Here second input is B, that is also plus, and the third input is C, that is minus. So this summing point with these 3 inputs will give an output A plus B minus C. So when we split the summing points into 2 also, the final output should be A plus B minus C. So first we have a summing point which will receive the signals A and B, and it gives output A plus B. And this A plus B is applied to the second summing point, and the other input to the second summing point is minus C. So this second summing point will give the output A plus B minus C. So this is how we can split the summing points. Combining summing points. This is just the reverse of rule number 8. Okay, we have 2 different summing points, and here we have combined it into a single summing point with 3 inputs. So this is very rarely used while doing block diagram reduction, because for doing reduction we have to split summing points. So combining cannot work, it will not work. Okay. Rule number 10, elimination of negative feedback loop. This is one that we have discussed earlier while explaining the effects of feedback. This one. Okay, we have a summing point over here, and we have a block with gain G in the forward path, and here see, if you look at the direction of signal flow, you can see that this is the output side. From output we are taking the signal and it's moving to the input side. So this can be considered as a feedback, right? So if you are having a system like this can be reduced to a single block. So in order to reduce such a kind of negative feedback loop to a single block, we have to apply this rule 10. Okay, so we are having a block with the gain G in the forward path, and we are having a block with the gain H in the feedback path. Then this can be reduced to a single block, and the gain of this single block will be this G divided by 1 plus GH. This is very important. G by 1 plus GH. Again, you have to remember that in order to apply this rule number 10, that is the elimination of negative feedback loop, you have to ensure that no branch point exists over here. Okay, the negative feedback loop that you are going to reduce should be like this. No other elements should be there. Suppose you are having a branch point over here, a branch point at the output of the summing point. Then in order to apply this rule number 10, you have to shift this branch point to some other point. To some other point means you cannot shift the branch point before the summing point. In that case, you have to shift this branch point to the output side. So after that, you can apply rule number 10. Okay, that you have to keep in mind. Usually students make mistakes in that. So if we are having a negative feedback loop like this, then can be reduced to a single block with gain G by 1 plus GH. And rule number 11 is elimination of positive feedback loop. So positive feedback means here instead of minus it will be plus. And the change that is going to happen is instead of 1 plus GH it will be 1 minus GH. So how will you eliminate a positive feedback loop? So this is a positive feedback loop and this can be reduced to a single block with the gain G divided by 1 minus GH. So here you have to keep in mind that G is the gain in the forward path and this H is the gain in the feedback path. If that is the case, then the overall gain of this particular loop will be G divided by 1 minus GH if it's a positive feedback loop, or if it's a negative feedback loop, then the overall gain obtained by applying rule number 10 is G divided by 1 plus GH. Okay, so this is very, very important. These are the 11 basic rules that we apply in block diagram reduction. Okay, so never use any rule other than these 11 rules. You may have a tendency to apply some other rules, but don't go for that. Okay, just go through these 11 rules and these are the rules to be applied in order to find the overall transfer function of a system using block diagram reduction technique. Okay.